So when you're talking about general polynomials, there are 4 to 5 things that you can see on screen, which is like division of polynomial, synthetic division, factor and remainder theorem, and mainly polynomial functions. And also to a certain extent, when you look at the sum of the roots and product of the roots. So sum of the roots and product of the roots. These are the product of sum and product of the roots. So these are the main key concepts that we need to talk about. And of course, now when you talk about factor and remainder theorem, you should know how to factor out a polynomial, how to factorize a polynomial. Factorize a polynomial. So these are the learning outcomes that we're expecting at the end of the 2 classes, and looking forward to at least cover up around 60 to 70% of the concept along with 2 or 3 problems. So now first thing is that when you're talking about the polynomial, the general examples that we talk is, let's say if you have a polynomial p of x represented by, let's say if you got something like x cubed plus 4x squared plus 3x plus 2, this is a polynomial of the degree 3. Now we refer it as a polynomial of degree 3, degree 4. So the highest degree that you have on any polynomial is referred as the degree of the polynomial, or highest power of x, you can say. Now, as far as the algorithms or like any problem solving is concerned, what we do is generally, let's say when you have, let's say for example, there is another polynomial, let's say p1x or qx. If I say, let's say qx is 2x squared plus 3x plus 1. Now with certain basic skills, you should be able to multiply. If you wanted to find out sum of the polynomials, q of x, difference of the polynomial, these are your presumed knowledge. So q of x, if you're multiplying p of x into q of x. Now these are something which is doable. Now p of x plus q of x, obviously you add the like term, so like answer will become x cubed plus 6x squared plus 6x plus 3. That's your sum of the this thing. And if you subtract the 2 polynomials, they're going to be x cubed plus 4x squared plus 3x plus 2 minus, so x cubed plus 4x squared plus 3x plus 2 minus 2x squared minus 3x minus 1. So when you're subtracting 2 different polynomials, you got to change the sign of the second polynomial. And of course, this will be simplifying to x cubed plus this is going to become 2x squared, 3x and 3x cancel, 2 minus 1 is positive. Similarly, when you're multiplying polynomial, you will multiply it as, let's say 2x squared plus 3x plus 1, that's my q of x, and my p of x is x cubed plus 4x squared plus 3x plus 1, px plus 2. I'm not going to do the entire procedure. I'm just going to talk in briefly what happens. So you multiply this with entire bracket, then this with entire bracket, this with entire bracket, and you add them up. So it'll be like 2x squared times x cubed plus 4x squared here. So 4x squared plus 3x plus 2 plus 3x times x cubed plus 4x squared plus 3x plus 2 and plus 1 times this bracket. So you're going to open up and simplify that. So this is like about your what you can say, the simple like presumed knowledge about the basic polynomials. Now some of the basic things that we understand is like, if you're not clear with indices, if you're not clear with like general expansion, you might not understand this. So make sure that you have a good idea about the basics of exponents and indices. So now what we have is the main thing that I would consider for problem solving in AHL for polynomials is the division of polynomials. Now, division of polynomials, I'll just explain through a couple of problems. Polynomials. So now, for example, if you divide a polynomial with certain number, let's say a number, first let's consider simple number division. If I'm dividing by 3, we get 2 as the quotient and basically 2 as the remainder. So remember, the algorithm is that you are dividing here by in a way that, you get the lowest number, so that this is no more a multiple. This can't be beyond that. Okay, so for example, I can't take 3 3s and 9 because that becomes higher than 8. So similar approach is also used when you're dividing a polynomial with the other polynomial. So let us say if you're dividing by a polynomial x cubed plus 3x squared plus 6x plus 5. If I'm dividing with another polynomial, let's say x plus 7. Now, when you're dividing, this is your divider, this is a divider. Here what you get is called as quotient, and at the end what you call here you get is called as remainder. So what we're going to do is we're going to understand the procedure in which, like, we used to divide the polynomial with another polynomial. So let's say if I'm dividing x cubed plus 3x squared plus 6x plus 5 with x plus 7. So what we're going to do is we are going to cancel out the first leading term. So we got to find out what should be the multiplier so that I get a number exactly x cubed down here. So as you see here, 2 3s are 6. We multiply here to get this number. So similarly, if I take x squared here, what happens is it's become x squared times x is x cubed plus 7x squared. So you're going to write x cubed below x cubed, x squared below x squared. Of course, how I got that is by multiplying these two. So if you subtract these two, you get this get cancelled, and you get minus of 4x squared here. So this is negative 4x squared. And after this, what we do is you further take the numbers down. So after this, what we do is you are going to take this down. 3 minus 7 is negative 4x squared. And these remaining numbers as it is. So like plus 6x plus 5 as it is down. So now here what we get is negative 4x out here. Now, because if I multiply x with negative 4x, then only I'll get negative 4x squared. So you take negative 4x squared, and then you take negative 28x. And if you subtract these two, what we get is this become positive. So this get cancelled. And this becomes, it's negative, this becomes positive. So this becomes 34x and plus 5. So after this, now you got to cancel this 34. So you take plus 34 here, so that you get 34x anyways. So you get 34x plus 7 times 34, whatever you get, minus this cancels, and you get 5 minus 7 times 34. So whatever that answer comes is the remainder out here. This is your quotient, and this is your divider. So that's how you do the general polynomial division in this kind of questions. So now let's take a standard specific form that we call the polynomials generally now are written. Let's say if you have a polynomial, you're dividing by a certain divider, let's say dx. This can be written as quotient plus remainder over divider. So this is a general format. For example, if I'm dividing, let's say 8 by 3, quotient is 2, and here we got as like 6, and this is 2. So now I can write 8 equals to, if I divide 8 by 3, it can be written as 2 plus remainder is also 2 upon divider, which is 3. And if you simplify this, you get as 8 by 3. So this is quotient plus remainder over divider. Now, if you multiply this divider other side, so what you get is sometimes you can write down a polynomial as quotient times divider, quotient times divider, you can say, and plus quotient times divider plus remainder. So any polynomial can be written as quotient into divider plus remainder. So this is another format which might be very handy. So now let's take a simple example which we have to write in this format. So lots of time they'll say that write down, for example, you're dividing by x cubed plus 6x plus 5 with x squared plus minus 1. So when you're dividing this, you have to write, let's say, x cubed plus 6x plus 5 over x squared minus 1 in the format of q of x plus remainder over divider, which is x square minus 1. So they'll say find the value, the quotient and remainder. At the end of the day, it's a division process. At the end of the day, you're dividing. So here, now one thing that you notice is there is no x and here is no x squared. So I generally like do this question like, without taking care of any missing term. But since it's a beginning phase, what I recommend to my students is always write down, instead of if there is no x squared, I can write down the 0x squared for that. And here, if there is no x, what you could do is either you want to write here or not, but I prefer to write down x squared plus 0x minus 1. So now what happens is that when you're dividing this polynomial, now obviously follow the standard procedure. You take here x. Now x times x is x squared, x cubed, and 0 times x is 0. So you can just write down 0 x squared, and x times minus 1 is negative x. So you don't miss out on anything. You don't actually miss out on any calculation because of the missed out 0 term. So like here you take minus, and it's both are 0. So this is anyways negligible. 6x minus x is 5x and plus 5. Now, surprisingly, this question you can't divide further, okay? Because if you're dividing by x squared minus 1 and your remainder you get is already linear, you cannot divide further. So you have to stop. So in this case, my quotient that you get is x plus remainder that you get is 5x plus 5 upon x squared minus 1. Now, this is also one of the interesting things that you use in oblique asymptote to find out the oblique asymptotes and all. So now I'll just take an example. How do we do that basically? Let us say if I have been given that x squared minus 3x plus 7 is a rational function and it is divided by x plus 1. This is my function and I wanted to find out what's the oblique asymptote for this question. So since we know our category is that of, obviously, as we might be knowing, if the degree of numerator is higher than degree of denominator, then it will have an oblique asymptote. Now here you have to revisit the concept of horizontal and vertical asymptote and all, but just remember that oblique asymptote only exists if degree of numerator, leading term, is greater than degree of denominator. Now there are different types of oblique asymptote. There are some linear oblique asymptote. There are some parabolic oblique asymptote. That depends on the difference in the degree. But in your syllabus for AHL, you have only the linear oblique asymptote. So let us just try to understand how we get that asymptote. So what we do is we do the long division, x squared minus 3x plus 7 upon x plus 1. And here what we do is you take this as x. If you multiply x times x is x squared plus x, and then minus, you get, here it goes, minus 4x, and this 7 is carried down as it. After this step, you take minus 4. This becomes minus 4x minus 4. This, if you subtract, this becomes positive, this cancels, this becomes 11. So when you're doing the division, kids, it's remember that x squared minus 3x plus 7 over x plus 1, the same expression can be written as x minus 4 plus 11 over x squared minus 3x, 11 over x plus 1. That's your divider. So if you take LCM of this expression, you're going to get back this thing. Now, the interesting thing is that what is the concept of oblique asymptote? Now, the concept of oblique asymptote is as x tends to infinity, whatever your y approaches to, that's your oblique asymptote, the similar logic to horizontal asymptote. Now, since your x is infinity, as you know that with the concept of limits, 11 upon infinity will be also 0. This will tend to 0. Now, if this is 0, my function actually will approach to y equals to x minus 4. So this will be my function's oblique asymptote. So this is how you use the simple polynomial division in multiple streams of problem solving. So what we are now from here onwards we're doing is there are two things that we get assessed on is called as factor theorem and remainder theorem. So when you're talking about factor theorem, and or remainder theorem, they have a link to the long division. Okay, so let us try to understand. So now here the question is x cubed plus 2x squared minus 11x minus 12. If you're dividing, let's say, by x plus 3 once, and on second time I'm dividing by x plus 4. And let us see what we get as answer. So first, when I'm dividing by x plus 3, here of course x plus 3, this becomes x squared. This is x cubed plus 3x squared here, and you subtract. So if you subtract, you get here as negative x squared, negative 11x, and negative 12. It's up to you if you want to take 2 terms at a time or 3. I prefer to go with 1 so that we don't have to look back to the first step. Then you have negative x out here, so that you get negative x squared and negative 3x. Because negative x times x is negative x squared, negative x times 3 is negative 3x squared, negative 3x. You take positive signs change, you're subtracting, so sign change. Negative 9x plus 3x is, this is going to be negative 8x and negative 12. And after this, you're going to take here as negative 8 maybe, and it becomes negative 8x and negative 8x minus 24. And if you subtract these two, you get positive and positive. This cancel, and your answer is positive 12. So what is now interesting is something with this. Now out here, you understood that there is a quotient, there is a divider, there is a remainder, and you have got x plus 4 here as well, x plus 3 as the, let's say, divider. Now what I'm going to do is, let us say if my polynomial p of x is x cubed plus 2x squared minus 11x and minus 12. What I wanted to do is I want to find out actually what's p of minus 3, and let's see what does that answer come to. So minus 3 cubed plus 2 times minus 3 squared minus 11 times minus 3 and minus 12. And when you find out, I'm pretty sure this answer is going to be 12. This is negative 27 plus 9 times 2 is 18 minus this become plus 33 and minus 12. So we take negative 27 plus 18 is, let's say, negative 9 plus 33 minus 12 you take is, let's say, 21, and 21 minus 9 is nothing but 12. So now from here, what we get is, you see across that there is a link. There is a connection to this method with that method. And now from that, we come to a very interesting outcome, and which is the origin, or you can say, which is the backbone of the remainder theorem. Now, what is remainder theorem basically? So when you're dividing a polynomial by, let's say, x plus a as a factor, let's say x plus a is your divider, p of minus a, if you find out, like here I was dividing by x plus 3, what you're going to just do is, if you're dividing by x plus 3, you equate to 0. And you solve for x, which is negative 3, and you replace x with this value, and what your answer you get, that is your remainder. So here you can see that I replaced x with positive 12, and I got the remainder also as negative 3, and I got the remainder as positive 12. Similarly, now I'm pretty sure if I wanted to find out what's a remainder when you divide by x plus 4, so in that case, you're going to replace x with negative 4. So replace x with negative 4 kids, and you get that as negative 4 cubed plus 2 times negative 4 squared minus 11 times negative 4 minus 12. And see what do we get after this. So we get is negative 64, and this is nothing but positive 16 plus 2 is 32. 16 into 2 is 32, plus this is 11 to negative 11 times, this is positive 44 and minus 12. And if you see that, this is nothing but 32 plus 32 minus 64. So that's coming as 0. Now, coming to this, my remainder is 0. Now, if my remainder is 0, we will call that divider as a factor, and this is the factor theorem. So factor theorem, when you talk about exactly the same thing, instead of getting the remainder as some number, you're going to get remainder as 0. So if the remainder is coming as 0, it means that that particular expression has that divider as a factor. So I would say that x plus 4 is a factor. And it will be interesting to actually see what's happening through this method. I would like to show it here. But is it actually becoming, let's say, 0 as a remainder? So here it becomes x squared, and this is x cubed, and this becomes positive 4x. So here you're going to get is negative 2x squared minus 11x minus 12, and then you're going to take here as negative 2, negative 2x. So it becomes negative 2x squared, and this becomes negative 8x. So this is negative 8x here, and negative 11x, negative 8x becomes positive 3. This is negative 3x minus 12 as it is, and then you take here negative 3. If I take negative 3, this becomes negative 3x, negative 12. And you can see that your answer comes to 0. So clearly, this is the link that you're talking about. So when you have divided a given polynomial by a particular factor, and that remainder comes as 0, we will call that expression which you your divider is a factor of that polynomial. Now, this becomes the origin, or this becomes a tool for us to factorize any higher order polynomial. And now, before I go on to the higher order polynomial here, once again, I reiterate that if you're dividing, now in general, if you're dividing, let's say, a polynomial x by ax plus b, then my remainder is p of minus b by a, basically. So remainder is p of minus b by a, and this is nothing but if you equate this to 0, whatever the answer you get, you just plug in place of x. That's what I mean. And if this is 0, we call it as a factor. So this is the summary of it. And now I'm just going to make use of this thing to factorize this entire polynomial. So let us see how do we do that. Not just coming back to the factorization technique. Now, so a tool that can add up to your speed is actually a method called as synthetic division. Okay, so synthetic division is actually just like touch base. There is a separate lesson on that, so you can refer that. Here, what we actually do is, in order to divide synthetic division with synthetic division, you just take the coefficients or the numbers right in front of them. So 1, 2, negative 11, and negative 12. And if there is a particular coefficient that was missing, now if assume that there was no x here, you would take 0 for that. So here you don't have to miss out on anything. You got to write down every single coefficient that you have. Now, for example, I'll do 2 questions parallelly so that you can be clear with the method. So let's say if I'm dividing x raised to 4, I'll take an easier polynomial. Let's say x cubed plus 5x plus 1. I'm dividing by x plus, let's say, 1. And I wanted to find out what's the quotient and remainder within seconds. So once you've written the coefficients here, so in this case, in the second case, I'm going to write down the coefficients as 1, 0, 5, and 1. And here, now next thing is that out here, you're going to write down negative 4. So you're going to just equate this to 0. So you get as x is negative 4. And here you're going to equate this to 0. So you get x is negative 1. So you're going to start with that. Now, what exactly is synthetic division? So in synthetic division, actually, all these steps are considered itself. So the first thing what you're going to do is the first number that you have here is brought down as it is. So first number will be brought down as it is. Then you follow standard procedure. So first number as it is, bring it down, and then you start with here. So we multiply these two. So 1 times negative 4 is negative 4, and place below the next one. So 2 minus 4, if you add these two now, you get negative 2. And negative 2, once again, you multiply with negative 4. So it becomes negative 8. Negative 11 and negative 8, if you add them up together, you're going to get negative 19. And negative 19 times, if you take negative 19 times negative 4, this comes out to be negative 19 times negative 4. So here, when you multiply negative 2 times negative 4, that's going to be positive 8. Now bring it negative 11, positive 8. If you add it, it becomes negative 3, and negative 3 times negative 4 is positive 12. And if you add these two, at the end, you're getting 0. And so what we get is the last number that is left is called as remainder. And here, this number that you get, this is constant number, this is the coefficient of x, and this is the coefficient x squared. So x squared minus 2x minus 3 is your quotient. And this can be very helpful in factorizing. So you already know that the quotient is x squared minus 2x minus 3. Otherwise, I had to do such a long division to get my answer for the what is the other quadratic factor. Because a cubic, if it has got the factor, that can be 3 linear factors, or it can be 1 quadratic and 1 linear. So I already got now 1 linear factor is x plus 4. The x plus 4 factor I already got. And now I've got x squared minus 2x minus 3. If you factorize this one, I'm pretty sure you get x minus 3 and x plus 1 also as a factor. So if you factorize this quadratic, you get that. Now, as a short summary, we got the factors of this, which is x plus 4, x minus 3, and x plus 1 as the process of the factorization. So you can use synthetic division, you can use long division. Nobody's saying that you use synthetic or long division at any stage, but you have to use with your logic, you have to use with the correction of time in your mind. So just remember that. I'll just complete this part so that our synthetic division method is clear. And in next session, what we're going to do is we're going to take more problems on factoring and graphing polynomials. So here what we get is the first number you bring down as it is. 1 times negative 1 is negative 1. 0 plus negative 1 is negative 1 itself. You multiply these two, you get as 1. 1 plus 5 is 6. 6 times negative 1 is going to be negative 6. And so your remainder here is you get a negative 5. And the quotient that you get is x squared minus x plus 6. So that's your synthetic division at its best. We'll do some practice problems next class. Okay, so from here on, what we are going to work on is on how to factorize a polynomial. Okay, so you have learned about quadratic splitting middle term. Then for cubic or quadratic, like for higher order polynomials, we have there's certain algorithm that we follow. So whenever you're finding out the factors of a polynomial, generally, if you could get the first factor or like at least 1 or 2 factors, then our life is sorted. Like we can basically plug in either like you use synthetic division or like long division to get the expressions complete factors. So now here we generally follow a method which is like trial and error. So you to find the first factor, you do trial and error. But trial and error is also directed trial and error. Now here, the possible factors of this expression will depend on 2 things. 1 is the coefficient of a leading term, and 2, the constant term. So you know that the constant term will be like somewhere like product of the factors and all. So what we do is we are going to take the factors of 4. What are the possible factors of 4? Plus or minus 1, plus or minus 2, and plus or minus 4. So you're going to take the factors of this polynomial, like this cubic polynomial will be one of these or like few of these. You will not have like x plus 3 as a factor for sure. So you have got possibly 6 factors in this polynomial. So what we should start with is trying x equals to 1, x equals to minus 1, trying x equals to 2, x equals to minus 2, x equals to 4, and x equals to minus 4. Any one of these, if gives me answer as 0, it means that is a factor of this polynomial. So let us try with x equals to 1. So when I try with x equals to 1, I get 1 cubed minus 3 times 1 square plus 4, which is coming as non-zero number. Now, hence, x minus 1 is not a factor of this. Now try with x equals to minus 1. Now let's try with minus 1. So if I try -1 cube minus 3 times -1 square plus 4, or -1 minus 3 plus 4, which is going to be 0. So now here 4 minus 4 is coming as 0. This is the answer which is coming to 0. So the trial and error gives us one of the factors already, which is x plus 1. Now after this, your smart work comes in picture. I would not say go for another trial and error. You can try with one more, try with 2 minus 2, and you can get other factor also. So what I can do is, if I have a cubic factor, already I found one factor as x equals to -1. What you could do is 1, do synthetic division and get the other quadratic factor, which is 1, -3, 0, and 4. That way you can test also if it is 100% factor. Okay, and now here what you do is you take this as 1 comes down as it is. This 1 comes down. So this one is basically 1 here. 1 into -1 is -1. Then -4. -4 times -1 is +4. And 4 times -1 is -4. And so you get answer as 0. So now you get the remainder as 0. That clearly indicates it's a factor of this polynomial. So you get x squared minus 4x plus 4 as the factor of this expression. I mean, of course, this is the quadratic factor. Now you can factorize it further. And obviously you can see this is like a quadratic x minus 2, x minus 2. It is x minus 2 whole square. So when you have to write down all the possible factors of this polynomial, it is going to be x plus 1, x minus 2 the whole square. So that's going to be the factorization, complete factorization for this expression that we have been given. So the factors of this is, these are x plus 1, x minus 2 the whole square. So that's how you factorize this particular polynomial. So now for this one, what we will have is a little different approach, which is you can see that there is a coefficient of x squared. So the possible factors that you will have are plus minus 1. So possible factors are 3 are plus or minus 1 and plus or minus 3. And unfortunately, if you plug any of these, when you plug x is 1, x is -1, x is 3, or x is -3, you won't get any of these as a factor. I mean, none of them gives us answer. So what we do is that if x plus or minus 1 could be factor x plus or minus 3, there can be other possible factors with the coefficient of x also, coefficient of leading term. So other possible factors can be 2x plus or minus 1 and 2x plus or minus 3. So once you write these ones and once you write with the coefficient of leading term. So these can be the 4 possible pairs of new possible factors, these. So now here, if I try x equals to half, you can try like 2 times half cube minus 5 times half square plus half plus 3 is not equals to 0. Similarly, if I try x equals to minus half, it doesn't come to 0. But if you try x with 3 over 2, so let's try and see what do we get. 3 over 2 the whole cube minus 5 times 3 over 2 the whole square plus 3 over 2 minus 5, plus 3. So this answer, let's see, it should come to 0. So 2 times 27 over 8 minus 5 times 9 over 4 plus 3 over 2 plus 3. And this is nothing but 4 here. So 27 minus, this is 9 times 5. So 27 minus 45 upon 4 plus, this is 2 3s are 6, 6 plus 3, 9 upon 2. So if you multiply this by 2, multiply this by 2. So this is 27 plus 18 minus 45, which is 0 upon 4. So the answer comes to 0. Now, So that clearly indicates that x equals to, so 2x minus 3 is one of the factors. So if I take x is 3 by 2, so 2x minus 3 is one of the factors. Now, since we've got 2x minus 3 as one of the factors, now you can long divide this polynomial or synthetic division. So if you do synthetic division, here you will be 2, -5, 1, and 3. And here you will be taking 3 over 2. In this question, you need to be a little careful when you're doing synthetic division, because this one already has the coefficient of x as 2. And here you're dividing by 3 over 2. So in short, you're dividing by x minus 3 over 2. You're not dividing by 2x minus 3, you're dividing by x minus 3 over 2. So what you do is you bring this down to this times, this is 3 minus 5 plus 3 is 2, -2, -2 times 3 is, this is again -3, and this is -2, -2 times this becomes +3, -3, this is 0. So you got the other factor as 2x squared minus 2x minus 2, but actually that's not the remainder, because if I take the second factor as 2x squared minus 2x minus 2, in short, you're getting the coefficient of x cubed now as 4, which is not possible. So what you do is, whenever you're dividing by, let's say, expression with the coefficient of x, the resulting quotient according to synthetic division will be exactly after you divide by that same coefficient. So let's say 2x squared minus 2x minus 2 is the quotient earlier according to this I'm getting. If you divide this by 2, if I divide this by 2, I get the new quotient, which is 2x minus 3, and it will be x squared minus x minus 1, which is pretty well fulfilling the condition that I need. Hence, this is one factor, this is the other factor. Now we see that this can't be factorized with the rational coefficients. So what you do is you can use quadratic formula and all in order, if you wanted to factorize in terms of irrational coefficients. So that's it. This is how you factorize the polynomial.